It'll make NASA great again.
Hello, everybody. Welcome to this week's Telescope Talk Hangout. My name is Tony Darnell from deepastronomy.space, and today we are going to be talking about telescopes, and in particular, the mounts and eyepieces that one uses to observe with. Now, these are important parts of the experience of going out under the night sky, and if you choose wrong, you end up having, well, you could have a pretty crappy night. So we're going to talk about the different kind of mounts that are out there, the different kind of choices, what they're good for, what they're not, what the advantages and disadvantages are. And then from that, in the last part of the hangout, last half of the hangout, we're going to be talking about eyepieces, which can mystify a lot of people. When you buy a telescope, and if you're a beginner, then you end up sort of using whatever comes with the telescope. And that may or may not be the best eyepiece to use for whatever it is you're trying to look at. So we're going to talk about the different eyepieces that are out there, and believe me, that's enough. And to understand how eyepieces work, we're also going to go into field of view, and that's how much of the sky you can see, and magnification. That's how big things appear in the eyepiece. And we're going to talk about what and the effect that those eyepieces have on those two things. So, without any more ado, let me bring in my co-hosts. On the top there, on the top right, is Adam Synergy Smith. Hi, Adam. It's good to see you. Welcome.
Hey, Tony. Good to see you too. Hey, everyone.
He got a NASA hat on, looking good. Also down in the lower right is not Dr. John Suffill. Are you a Dr. John?
Oh, yeah.
John Suffill.
Why not? Why not?
You're John Suffill, UK amateur astronomer, and Adam is also. I want to give a shout out to his podcast, Unseen Podcast, which is a great program you guys need to also check out. So you guys see, I have a new toy to play with. Slowly but surely, the hangouts are changing over time, and I am trying to make things a little bit better. Many of you have requested, hey, can you get a set up so that you can look at all the different guests? So now we have the astronomical Brady Bunch here. I'm not going to sing the song. I'm not going to. Do you guys know the Brady Bunch? I'm not singing that. Here's a story.
We're English, Tony. We don't sing the Brady Bunch song.
Oh, well, okay, you're right. Then I won't do it either. So anyway, we hope like the new setup. It makes it easier for us to all talk and you see us all at the same time. I want to also say at the top of this hangout that well, let me start by saying we're looking at the live chat on YouTube right now. And both Adam and John are actively participating. They will read out your questions and comments. So please deluge us with questions and comments. We want to see them. We want to hear what you got to say. I have the Facebook page up, and I'm looking at Facebook comments as well. So please feel free to leave your comments on Facebook. And I'll see them because I'm looking at them right now. So that's the best way you can do this. And finally, the last announcement I want to make is that we want to continue this conversation. I'm going to do this with all of my hangouts. Deep Astronomy now has a channel or a station on anchor.fm. So if you want to continue the conversation after this hangout is over and you missed it live, then leave a call in on anchor.fm/deepastronomy and ask your question, and I promise I'll answer it, because right now nobody is listening to me on Anchor, and the more call-ins I get, the more I am likely to respond to your questions, so it gives me more content to make. So please follow the conversation if you missed it live on anchor.fm/deepastronomy. Okay, well guys, we're going to talk about telescope mounts first. Let's do that topic first. Do you guys have any opening introductory remarks about mounts? Anything that you want to say before we go into them?
Well, most people tend to think of a telescope as being the tube with the optics in it. And that, of course, is an essential part of a telescope. But it's really important that you have a good mount as well. Equally important, I would say. If you haven't got a nice, steady, sturdy mount, you're not going to be able to see very well through the telescope. The image is going to jump all over the place with the slightest knock or unsteadiness. So it's a really important piece of kit that you need to get the best out of your telescope. And there are different kinds of mounts that I'm sure we'll go into.
John, do you have anything you'd like to add?
Well, Adam was right when he said that a lot of telescope mounts, you've got to get a good sturdy one that's going to fit the size and weight of your telescope. If it flops about all over the place, you're not going to get anything out of it.
Yeah, I would argue that the mount is as important, in some cases more important than the optics of the telescope that you've picked. And I know that's a little counterintuitive, but when you've got good optics and a nice sharp image, that's useless to you if you've got a mount that is shaking so bad that when you try to look at it, all you're seeing is people stomping around, everything else, walking around while you're trying to observe. So the mount is hugely important. And there are many, many kinds of mounts. And John, if you wouldn't mind, would you mind putting up that graphic you have of the different styles of mounts?
Yep.
And while you're doing that, I'm going to do this. And
this is the one.
Okay.
Yeah, that's the one. This is all.
Okay, so I'm seeing a lot of images here. There we go. That's the one. There we are. Awesome. Thank you. Okay, let me just rotate this a little bit closer. Do this and make it bigger. Okay, so what John's put up here is a diagram of 3 different types of mounts. There are others, but these are 3 of the most popular, with the exception being a fork mount, which we'll talk about in a minute. You guys want to comment on this, or do you want me to just go through?
Well,
go ahead, John.
Yeah, the altazimuth mount is one of the most basic mounts. But, the telescope moves up and down. That's the altitude, and left and right. That's the azimuth.
Yep, that's all it does. Up, down, left, right. Right. So.
Yep.
Yep.
Next one along is a Dobsonian mount, which is a variation of the altazimuth mount. Again, it moves up and down, left and right. The equatorial is a lot more complicated. It's got a polar axis, which you have to align to the North Pole, or if you live south of the equator, the South Pole. And then instead of moving the telescope on 2 axes, up, down, left, right, you only have to evolve it, turn it on the declination axis. So it makes tracking a lot easier.
Right. So a mount has 2 essential jobs. It has one. It wants to hold. Actually, it has 3. It wants to hold the telescope steady. Is its first job. The second job is to let you move and point it at things in the sky. And in many times in both altazimuth mount and in a Dobsonian mount, it stops there. But with a German equatorial mount, it's actually polar aligned, where the polar axis, let me put that back up again. You see in the equatorial mount, there's a polar axis. That polar axis, John's pointing to it right now, that polar axis points directly to the North Star. And the challenge to these telescopes is to get it lined up on the North Star. And that used to be a real pain in the butt to try and do. Now, this equatorial mount picture has it on a concrete pier, which presumably you set it up once and you're always aligned to the polar axis. But if you've got a portable telescope, then everywhere you go, every time you set up, you have to realign it to the North Star. And when you've done that, then what it does is when you turn on a motor or a clock drive, it counteracts the rotation of the Earth and allows you to keep one thing in the eyepiece, in the field of view, at once without having to have it drift out. If you ever look through a telescope with a non-clock driven alt-azimuth mount and you point it at something like the moon and you leave it alone, you're going to notice that the moon or the planet or whatever it is you're looking at is slowly going out of the field of view. That's because it is not compensating for the rotation of the Earth. So that's a equatorial mount with it's got a polar axis like this one does will allow you to do that. So okay, John, if you go ahead and stop sharing your screen and then maybe put up the fork-mounted version of that. We will talk about a fork mount also.
Yeah, if I can
Okay.
find the one he's looking at.
All right, and so now the fork-mounted telescope is like it sounds. It's got two arms on either side of the telescope tube, and John will put this up in just a minute, and you'll see. And the fork arms will form the polar axis. Actually, there's two configurations of a fork-mounted telescope. You can have it in an alt-az mode, in which case, if these are the forks, it goes side to side, and the telescope tube can go up and down like this. Or you can have it polar mounted, where the fork mounts, the forks themselves point toward the North Star. So those are two configurations. And let's see, John, yeah, he's got that up there. So what you're looking at here is a fork-mounted Celestron Schmidt-Cassegrain telescope. The things you'll notice on this are there's a fork that the telescope tube sits in, and there's a wedge at the bottom, at the base of the forks. The forks themselves just hold the telescope up and let it go up and down. If they were flat in an alt-azimuth configuration, then it would be just like a Dobsonian telescope. But because these have a wedge on the bottom, that wedge is allowing the fork to point at the North Star, and it can track the sky without losing the object in it in just one axis. You want to add to anything to that, guys?
Adam?
No, just that generally speaking, equatorial mounts are cheaper than fork mounts are cheaper than equatorial mounts and easier to use.
Yep.
So if you buy a fork mounted telescope, you can spend the money you save on a cheaper mount on better optics.
Right, and so we should probably get into that just a little bit. If you could stop sharing your screen, John, I'll put you guys back up.
Yeah.
So the three designs that we showed you, the alt-azimuth mount and the Dobsonian mount, which are kind of the same, just different shapes, and the fork and the equatorial mount. Generally, alt-azimuth telescopes are both simple to use. They require no polar alignment, and they're generally cheaper because they don't have a clock drive on them usually. Now, you can put a clock drive on an alt-azimuth mount, but you need two motors. One to as the object moves across the sky, it has to rotate the telescope, but at the same time, it has to also change the azimuth of the telescope tube as it's tracking, because it's got two axes. It's not polar aligned, so it's got two different things to correct for. Am I saying that right, John?
Yeah, that's right.
Okay,
yeah.
So you need, it's a little more complicated if you want a clock drive and alt-azimuth telescope, but if you put a clock drive on a German equatorial or a wedge-mounted fork mount, then you only need one motor, and that motor has to be one revolution per day. It could be a very simple mount, a very simple motor that is basically a clock motor. That's why they used to call them clock drives. And they would take a clock motor, which is designed to measure the time of day, and put it on a worm drive, and then they would put that worm gear onto a bigger gear, and they would just act like a clock, and it would go the opposite direction of the Earth as it rotates, and keep whatever it is you're pointing at right in there. So those are some very basic mounts, and those are an introduction into clock drives. We're going to have a whole episode on clock drives and go-to telescopes, so we're not going to talk about that too much today. We just want to get you introduced into the different kinds of mounts. Now, I guess my question to you guys is, as observers, what advice would you give to a beginner as to which type they should look at?
Alt-azimuth.
Why is that?
Or Dobsonian. It's a lot simpler to set up. An equatorial takes maybe 20 minutes, half hour to set up properly. An alt-azimuth or Dobsonian, you just take them outside, you plonk them on the ground, and you're going.
Okay.
Yeah, I'd agree. For a beginner, alt-azimuth or Dobsonian, much easier to use.
Yeah,
easy
you're
to
going
set
to hear us go on about Dobsonians for beginners, because really, point blank, they're the best freaking telescope out there.
Yeah.
But go ahead.
If you're interested in doing deep sky imaging, you're probably going to need an equatorial mount. But for a beginner, you don't need one straight away. If you're serious, if you're buying a telescope and you're serious about getting into deep sky imaging galaxies, nebulas, that kind of thing, then maybe you ought to buy an equatorial mount. But otherwise, alt azimuth every time.
Yeah, John, while I say what I'm about to say, could you please search for that alt azimuth fork telescope that you had before we started? I'd like to show that. You showed one with a wedge. If you could show one without a wedge, and then I'll put that up. But I just want to say that when it comes to German equatorial mounts, there is a wide range of quality that is associated with these. Some of them are absolutely crap. Now they're a little bit gangly. They've got a polar axis that points to the North Star, but they also have another axis on it that is it's a balance. It's a counterweight to the telescope itself. And there's actually a lot of torsion and not friction so much, but flexure in these mounts, because when you got a big old weight hanging off of the end of the telescope tube to kind of balance it, it ends up flexing all of these shafts that are in the mount. And if they're not built right, they could be real crap, and they can be very shaky. So German equatorial mounts, there's a wide range, and they're not very, the ones worth using aren't very cheap. I would say they're around $400 to $500 for the decent German equatorial mounts. Now with fork mounts, you can get away with a cheaper telescope, and they will work really well. But fork-mounted telescopes generally only work with really short tubes. If you'll notice, when we showed the German equatorial mount, real long tube, like a Newtonian reflector or a refractor would sit on one of those. But with a fork mount, they tend to be short, stubby telescopes like Schmidt-Cassegrains or other cat optic telescopes. And that's because if you get a big telescope in there, like a long Newtonian, you've got to have long fork arms to put that in, and they tend to add a lot of weight. And back in the old days, Edmund Scientific made an 8-inch fork-mounted Newtonian telescope, which was an f6, so it was about 4 feet long, the tube, and about a little over a meter. And it was awesome. It was really cool, and it was really beefy, but it was also really expensive. In $1980, it was like almost $900 for that telescope, and that's because the casting for the fork arms, that was my dog, the casting for the forearms was very expensive. So, John, do you happen to have that handy?
Yeah, I think so.
Oh, okay.
But it's not a very good photo
of the. Well, you showed me one that was pretty decent.
Yeah, I couldn't find that one again.
Oh, okay. All right, let's see what you got here.
No, that's not the one.
That's me. No, I am not a fork-mounted telescope. Okay, well, while you're doing this, Kiran Kumar is on Facebook and is asking, is it like a horseshoe mount? You mean the fork mounts? Yes, they are. They're like a giant horseshoe shape, if that's what you're asking. And he's also asking, the big telescope, which mount is more portable? That's a great question. Which would you guys say of these mount designs is the most portable?
Well, the alt-azimuth mount you can take apart, so you get the tripod legs and then you get the mount. The Dobsonian mount, it's always going to be a bit of a lump.
It's going to be what?
A bit of a lump.
Oh yeah, because it's gonna always be the same size. The telescope tubes are usually really long and heavy, but the mount itself isn't that bad. But you can, if you buy like a Meade light bridge Dobsonian, those have truss-mounted tubes. Those are, instead of having a big solid tube, it has a little trusses that hold up the secondary mirror, and you can collapse that down so that the whole thing all fits into the trunk of a pretty small car, or the boot of a pretty small car. But I guess overall, a fork mount would be more portable. Usually, they fit. Usually, those telescopes and the mount will all fit into a trunk or a case that you can put in your trunk. I was hoping to show you a a fork-mounted alt-azimuth telescope. But basically, it's the fork-mounted telescope that's just sitting flat. The two forks are pointing straight up into the sky, right overhead. And by the way, the name of the point of the sky directly over your head is called the zenith. That is the point directly over your head. And so, so the fork mounts that are pointed straight up, they go side to side like this, like my office chair, and the tube can move up and down like this. That's alt-azimuth.
Alt-azimuth telescopes don't generally need counterweights. Generally speaking, you can get ones with counterweights, but generally speaking, you don't need them.
That's right.
But
Sometimes, I'm sorry. Go ahead and finish.
You do with an equatorial mount if you've got a big telescope.
Yeah. There is David Leapart is also commenting on that makes a good comment. Of the fork mounts, the double arm works best. I get a lot of vibration with the single arm. We didn't talk about that, did we? There's some you can buy that aren't. It has one fork, and the telescope is just mounted right here, right?
That's right. Yeah.
So
a fork can have either one or two times. One upward.
Yeah, but David, those tend to be smaller telescopes, the little smaller, like 4-inch size Cassegrains, things like that. We're going to have a whole episode on Schmidt Cassegrains, by the way, because they're a complicated telescope. But those tend to be a lot of the really cool short telescopes you see advertised. And I don't know, but I haven't seen any decent sized ones for under $500 that have go-to mounts and all that kind of stuff. But maybe there are. I just haven't looked. But yeah, there are. You can get them with one arm or with two arms, in which case you need. But the one with two arms is more stable. And really, I cannot say this enough. When it comes to a mount, the stability is everything. How much does it? How well does it hold the telescope? How easy does it track the sky? How easy does it push when you get it? And does it stay pointed when you get it there? If you've got some wobbly telescope, believe me, I've seen them. They're on tripods, and they're generally a German equatorial. Somebody walking behind you, or your dog even walking behind you as you're trying to look up at the sky, and you're looking at the eyepiece, all you're going to see is this vibration everywhere. It's going to be, it just will ruin it. So I would. John keeps sharing his screen.
I'm still trying to.
You trying to find that? You trying to find that image for me?
Is that's worked?
Let me look.
I've had too many windows open.
Okay. Yeah. Can you just select that image? Just pull it up.
Well, that's as good as it comes, unfortunately.
Oh, okay. Well, we'll just scroll that, and I will center this a little bit better. Okay. Oops. Let me center it more. There we are. All right, so what you're looking at there, folks, is a Meade fork-mounted telescope. I'm not reading the article, but you can see that there is a optical tube assembly sitting between two forks, and those forks are pointed straight up, and that's pointing at the zenith. It's not pointing at the North Star unless you tilt those fork arms to whatever your latitude is and point them at the North Star, and then it will become a polar aligned equatorial mount. Now, these telescopes, when you buy them, they have a clock drive, and you tell it which mode it's operating in, or it has a computer, and you tell it which mode you're operating in. Are you in alt-azimuth mode, or are you in polar aligned mode, polar mode? And if you're in alt-azimuth mode, and it runs both motors. There's a motor on both axes, the declination axis, which is where the tube moves up and down, and the azimuth axis, which is where it goes around in a circle. And so it'll run both of those. But if it's a polar aligned mount, it's only going to run the azimuth, the right ascension mount, because it doesn't need to operate the declination one, unless, of course, you did a crappy job aligning it, in which case you're going to have to correct for it once in a while. But these telescopes are they've become a lot easier to set up now. We're going to go into that in another one, but I want to give you the basics of the mounts right now. Do you guys have anything you want to add to what I just said?
No, Adam.
No, not really. Galaxia is asking, why is it called a German mount? I guess
German equatorial.
Yeah.
Yeah, why is that? I don't know.
Probably it was
You got to-
invented
well, you
by
got to
someone
give it-
German.
Yeah, you got to give them the benefit, for some things.
Okay.
There is an English fork mount
That's right. Yeah.
and a German equatorial mount. Just the way it is.
Yeah, it must have been developed by somebody in Germany. And they tend to be, I don't know, John, how handy that German equatorial picture might be, but if we might be able to pull that up again, we can talk a little bit about how complicated they are. I find them to be real difficult to use because they are generally very heavy. You've got to deal with that counterweight on the other side of the axis as your telescope tube. And if you've got a big telescope, you're looking at a big counterweight. And getting all of that balanced, I've always found, is a real pain in the butt. So I've never liked German equatorial mounts, but a lot of people use them. I've always preferred the fork mounts as that goes. Kiran Kumar, again on Facebook, thank you for asking questions. He's asking how to polar align the equatorial mounts from locations where the pole star is not visible. Now, actually, let's talk about that a little bit. There are several ways to align your telescope to the North Star, and the hardest one to use is to try to use the North Star directly. Do you want to talk a little bit about, John and Adam, about how you polar align your scopes?
Well, I use the pole star.
You do? Okay.
Yeah.
So,
On mine, the EQ5 equatorial is a little telescope with the polar alignment, polar axis, and that has a circle, well, a double circle, really. And what you do, you find out first of all on an app or something like that where the pole star is at that moment in time, and then you adjust the altitude and right ascension of the equatorial mount, so that the pole star is directly in that spot where the thing should be.
and that's how you find that easy.
No.
I was gonna say. Yeah,
I must admit, I've been doing astronomy that long that I know exactly where the pole star is. I could go outside now, even though it's daylight, and point to the patch of sky where the pole star is.
I know, but that's different than trying to get your telescope lined up to point right at it, isn't it? I mean,
very different.
Yeah,
very different. Yeah.
So,
well, one problem is it's so low down. You've got to crouch down, and I'm not getting any younger. So it's
yeah. Well, there's another method. I'm only going to mention it. I'm not going to go through the details of how to do it. It's called the drift method. And you look at a bright star somewhere near the meridian of your location, and we'll talk about what all that is at some point. But you want it sort of right in at a point about 45 degrees up from the sky, about where you are, or up from the horizon, I mean. And then you align the telescope using the dials as best you can, and then you get it kind of pointed at the North Star, and then you look at the bright star, some bright thing, at a high magnification as you can stand, and look and see which direction it drifts out of the eyepiece. And then you compensate by turning the knobs a little bit on your adjustment knobs on your telescope to compensate for any drift that you see, until it finally stops drifting altogether. And that's the way I've always used to polar align my scopes. It's very accurate because at high magnification, and I'm talking something like 100, 110 power, then you're able to get a really accurate correction for the drift. And so that's how I usually do it. We don't have a telescope to actually step you through the process, but if you look up drift method on Google, you'll see a good way to polar align. So good question, Kieran. I appreciate that. And finally, before we move to eyepieces, let me ask his question on what is the cost difference between the different types of mounts. What's your experience with that, guys?
Well, I just I recently bought an AZ4 altazimuth mount that was £140. The EQ5, I don't know offhand how much that is, maybe about 250.
Mm-hmm. Adam, do you have anything to add to that? Your experience with cost?
Only that fork mounts generally are cheaper.
Yeah, that's probably true. They tend to make more of those. They tend to be part of a telescope system. And the go-to mounts, which are ubiquitous now, are actually dropping in price quite a bit. So I think the cheapest might be Dobsonian, just because of its lack of
anything
stuff. Yeah, it's just simple. It's easy to make. You can build them out of plywood, and that would be the cheapest, followed by, I think, maybe the fork mounts, as Adam said. So, yeah, I think that's. But if you want to follow the sky, and this is important if you're going to be looking at things for longer than, say, 5 or 10 minutes, or you're going to go away for a while and then come back. You want to be able to still have it centered in your eyepiece. Clock drives are important. That'll be, like I said, that'll be the focus of another hangout where we talk about go-to telescopes and clock drives. But for now, we're just talking about the mount designs. And I'm going to just ask for you guys' comments on stability in general. Which do you think, of all of the altazimuth, I'm just going to say that, including Dobsonians, German equatorial or fork-mounted telescopes, which do you think are the most stable? I know expense and quality and manufacture, but as designs go, what do you think?
Designs. Oh, I'd have to go with an equatorial.
Really? You think it's more stable than a Dobsonian?
I'd agree. I think that they are worth having and setting up, particularly if you've got a big, heavy telescope.
I think that's a European bias.
Yeah. David Liebhardt is saying that the German equatorial mount goes back to Joseph von Fraunhofer in the early 1800s.
Well, there you go, folks. Good. My good old friend von Fraunhofer. And he's actually a physicist, so did some work on optics, I believe. So good. Thank you for that. That's cool. Cool. I think it's Dobsonian. Sorry, I just do. You can kick them, you can move them around, and they're pretty stable. And they've got a wide footprint. They sit on the ground. They absorb vibration pretty well. And I don't know. I just think they're the most stable. I think German. If I had to say which was the least stable, I would have said German equatorials.
Yes. Well, if you buy something like an EQ8, and they cost several £1,000s, and you could build a house on top of it.
Okay. All right. I think the German equatorials are also very hard to polar align. I find fork mounts much easier to polar align, but then I've owned more of those too, so I probably have a bias with respect to that. Okay. Well, we're about halfway through our hangout. I want to move on our topic now to eyepieces. Eyepieces are the second biggest thing, and John and Adam wears his around like a monocle. Eyepieces are this thing that goes into your focus tube of your eyepiece, and without it, you don't see anything. So they're hugely important. They take the light that comes down from the objective lens, it bounces off the secondary lens, and then goes into your eyepiece, and it is what takes that light from the focal plane of all those optics and makes an image. And the two biggest things that characterize an eyepiece are the field of view that it shows you, and that means how much of the sky can you see when you look through it, and it also determines the magnification that you operate. Now, magnification and field of view are highly related, except when you talk about a Nagler eyepiece, which is something we'll get to in just a bit with the different designs. But would you guys comment for me on how important you think those two things? Well, first of all, tell us what, in your own words, what field of view is, and then we'll talk about magnification.
Oh, the apparent field of view of a eyepiece is how wide you're looking through. field of view, and you're going to be looking through it's like we said before, looking through a straw. A wide field of view, it's going to have the same magnification, but you're going to be able to see a lot more. And there's eyepieces now that go up to 110 degrees field of view. Now, that's not to say that you're going to see 110 degrees looking through a telescope. This is at the eyepiece.
Yeah. And what about magnification, John?
Magnification, that is, you can easily find out magnification by...
Yeah, I'll tell people how to calculate it in a minute, but I just want to see tell us what, in general terms, magnification is.
Well, the higher the magnification, obviously, the bigger things are in your eyepiece. Big things in your eyepiece is not always good. You don't always want the highest magnification that your telescope can take. Most of my observing is done up to about 100 times magnification, and quite often a lot less than that.
Right. I agree, totally. Adam, you want to add anything to this? Just general comments on what you think field of view and magnification are.
Generally speaking, the higher the magnification, the smaller field of view you'll get.
Yep. That's how they're related. So they're two intertwined things. As John and Adam have said, the field, what you typically want is a wide, if you're looking at large objects, something like the Orion Nebula or the Andromeda Galaxy. These are very large objects in the night sky, and you want to try and capture as much of it as you can if you're interested in seeing the entire thing. But when you add an eyepiece with a high and you generally get wide fields of view at low magnifications. So looking at the sky with a 50 power eyepiece, we'll see a certain chunk of the sky. You might be looking at the Ring Nebula in Lyra and see a little teeny tiny little dot, but you'll see a lot of the sky. But if you've got a higher magnification, you're going to see less of the sky, and that little teeny tiny dot of the Ring Nebula gets bigger. And it might actually look like a smoke ring, like it's supposed to. You might actually see the donut shape of the Ring Nebula at a higher magnification. The problem, of course, is if you add a higher magnification eyepiece, yes, the Ring Nebula will get bigger and your field of view will get smaller, but it will also get dimmer because you're spreading out all of this light over a bigger area. And you're not just magnifying the light from the Ring Nebula. You're also magnifying the turbulence in the atmosphere. You're magnifying the vibrations in your mount. All of these things are going to start getting shaky, and if you're out on a hot summer night, the atmosphere is going to be boiling at high magnification, and you're essentially not really improving things all that much. So what you ideally would love to have is a high magnification and a wide field of view, and that's hard to get. But there are eyepieces that give you those things. Alexander Rangers is saying, wrong, Tony. About what? What am I wrong about? Oh, I'm never wrong. What am I wrong about? So anyway, that's a brief introduction into field of view. You want a lot of field of view when you're looking at things like the Orion Nebula, but you don't necessarily want it so much when you're looking at planets like Jupiter. You just want to see Jupiter when you're looking at Jupiter. And so a field of view that is smaller is a good thing, and you kind of want as much magnification as your telescope can stand. And that may not be as much as you think. If you've got when we talked about this on our first hangout, a department store telescope that advertises 1,000 power, no, you're not going to get. You're going to have a very unsatisfactory experience. But you might want to look at Jupiter at, say, 100 power. That would be. I'm like John. I've never seen a situation where I could actually go more than 100 power. Anything over that is too much. Now, here's the way you figure out your magnification. We talked about focal lengths of telescopes in the first episode. That is how much distance the primary mirror needs to focus the light to a point. It's usually advertised in millimeters. A 2,000 millimeter focal length telescope means that it takes 2,000 millimeters to focus light for that objective lens to focus it to a point. And now, eyepieces also have a focal length, also expressed in millimeters. Let's say a 20 millimeter telescope, a 20 millimeter eyepiece, or a 40.
This is a 20 millimeter eyepiece.
Okay, it says it on the side. Hold it real steady, if you can. Can you get it? Can you get it to show?
I don't think you're going to be able to see it.
All right. Well,
I'll put it.
Okay.
Far too small to see.
Okay. Well, they're usually, they have a focal length of their own. Eyepieces are essentially mini refracting telescopes, and they have little optical lenses in them. And John has a great graphic that he found that shows some of the different designs of eyepieces. And while he's pulling that up, I will. I will just go into a little more detail. So the way you figure out the magnification that you're operating, it's very simple. You divide the focal length of your eyepiece, let's say 20 millimeters, by the focal length of the telescope. Okay, and if it's 2,000 millimeters, you're working at about 100 power. So that's the way you would figure out your app. Just divide eyepiece into focal length. Make sure you have the same units. You don't want inches divided into millimeters, or you don't want to divide millimeters into inches. You won't get anything that makes any sense. So you keep the units the same, and you get the magnification. It's just a number. It doesn't have units. It is like magnification of 10. Well, a magnification of 10 usually means that the image that would be shown on the focal plane of the telescope without an eyepiece is magnified, is 10 times larger than it would have been with the eye, or it's 10 times larger with the eyepiece than without the eyepiece. So that's what your magnification is. It is basically a size, something 10 times larger. And when you take something very faint and you magnify the crap out of it, you make it even dimmer. So you can only, you reach a point where you don't see anything if you go at too high a magnification. So please remember, magnification is not the end-all and be-all of a quality of a telescope. In fact, it means nothing about the quality of the telescope. It just means I can take an image. If you see a telescope advertised for it to be 1,000 power, all you're learning is that this thing says it'll take an image that's going through the telescope, make it 1,000 times bigger. And, well, who wants that? That's just, and it's not really even possible or practical. So let's take a look here, John. You've got, hang on just a sec here. I have to do some shifting. There we go. Okay, you've got a Wikipedia page up that shows different, can you zoom that in a little bit? Make those diagrams a little bit bigger? Just hit Control Plus or Open Apple Plus or whatever you're using. There you go. Okay, so here you're looking at some different designs of eyepieces. There are many different kinds. Stop right there. One of them was RKE. Go ahead and just hold it there with the RKE. Yeah, let's take a look at that. Let me just get it lined up. This RKE is one of the simplest eyepiece designs that you can find. Now, on the left side there is the focal plane of the telescope. That's where the light is being focused. Those three optical elements to the right of that are the lenses that make up that eyepiece. And this is simple, folks, and it's got three. And it's designed to magnify the focal plane as well as give you something called an exit pupil, which is how big the thing will appear on your retina. And that's another topic that we will probably get to in another hangout. But exit pupil is an important factor as well. In terms of how well you can see things. In fact, I'll probably talk about it in just a little bit. But so scroll around, John, and let's take a look at the Koenigs, the Koenig eyepiece that you see up there. That's it's a variation on an RKE. The Erfel, that's another very popular one that was back in the day that you could see lots of. But look at all those different lenses that are in eyepieces. All of these, I don't know what a monocentric is. I've never seen one of those. That's weird. Okay, go back down to Plossels. Plossels tend to be the most popular in this day and age. If you buy a Celestron or a Meade, they'll get you one. You'll get one with it, usually a 26 millimeter or 40 millimeter. Yeah, there's a Plossel. Those tend to be the most popular. Would you guys agree that those tend to be the most popular now?
They're very good.
Yeah, since the 1980s, yeah.
Right, and they're a design that it takes. They usually have they have 4 optical elements, one inverted on the other. They have the advantage of giving you a wide field of view and some relatively high magnification. So they're very nice eyepiece designs, and they usually come with a Celestron or a Meade if you buy one. And they might even come with some of the Dobsonians. I don't know, but these tend to be the standard now. But the last one I want to talk about, go to Nagel's.
Naglers.
I'm sorry, Nagler. Sorry, what Nagels? Naglers. Naglers are a eyepiece design that was designed by Ralph Nagler.
Amazing.
I'm kidding. Nagler was the owner of Televiews. Robert Nagler was his actual name. And
it says here Albert.
Oh, was it Albert? Oh, sorry. Albert Nagler.
Robert was his twin brother.
Yes. So there you go. He owned Teleview. I don't know if he still does or not. But Teleview is an eyepiece company. And they sell the absolute best eyepieces in the world. They're very expensive. They can cost more than a telescope. But they have look at all those optical elements in there. That's a lot. And they have the distinction, I think, of being the best eyepiece you can buy. If you can buy a Nagler, buy a Nagler. I've never been disappointed by those. And they give you wide field of view, good image quality, high magnification, typically, and good eye relief, which is how far away your eye has to be from the eyepiece to see anything. It's a very comfortable experience to look through one of these Nagler eyepieces. So they're very, very high. I highly recommend them. Do you guys have any Naglers?
No, unfortunately.
Yeah, they're really expensive. I only had 2 when I had mine. I had a 7mm and a 18mm, I think. And I used them for the planets mostly. I would put them in my Meade telescope and look at the planets using those. I really enjoyed it. So okay, so you can stop sharing your screen now, John, so we can get you guys back up. And
eye relief is quite important, Tony.
Why don't you talk about it then?
Well, it's how far away from the lens your eye needs to be to see the image. If you have to have your eye squeezed up against, right up against a lens for a long time, it's really no good. Mm-hmm. You need to be able to see reasonably well from at least a small distance away from the telescope. You don't want to be fastening your eyelashes up against the telescope.
That's right.
It sounds silly, but it's important.
No, you'll notice it the minute you start looking at high magnification and I wear glasses, so eye relief is really important. The further back I can get from an eyepiece, the better it is for me, because I can focus with my glasses on. If the eye relief is really close to the eyepiece, I have to take my glasses off, get right down in there on the eyepiece, and then focus it for my eyes. So I appreciate the eye relief part. Another important part is exit pupil. And the exit pupil is the physical size of the image that you see in the eyepiece. And you need it to match your retina as much as possible, because if it's bigger than your retina, you're throwing away light. If it's smaller than your retina, then you're not optimized for your own eye. So you want an exit pupil that's around 7, I think it's 7 millimeters. It's measured in diameter, and I think your pupil, does your pupil get up to 7 millimeters? Can it get that big?
Yeah.
It depends on your age.
So so if you're older, it doesn't get as big. Is that what happens, or?
That's right. Yeah.
Okay. So for people like me who are too old, my eye doesn't open up as much, my pupil, but you want to try and match it up as much as you can so that you're not throwing away light. So exit pupil is something that Naglers are really good at. Plossels are also very good at. RKEs and some of these other designs, not so much. And Kieran Kumar is commenting on Facebook. He goes, is Nagler a brand of eyepiece? No, it is a design of eyepiece. The brand would be Teleview. I don't know if other people make Naglers. I think Teleview is the only one that can make them, because he owns the patent for it, and he also owns the company. Toxic Vamp is going, I hear a budgie.
That's mine.
What's his name again?
Blue.
Ah, so there you go, folks.
Because he's green.
Alfred Nagler. I know, we got it. I said it wrong. I said Robert Nagler, and then I said Ralph Nagler. That was a joke, though. I said Ralph Nagler because it reminded me of Ralph Nader, and Ralph Nader was a presidential candidate a couple of decades ago. So, yeah. So I was kidding about Ralph Nagler. But you're right. It's Alfred Nagler, and he owns Teleview, and he also invented the Nagler eyepiece design. Okay, Kieran's also asking, what's a Barlow? Oh, man. That, who wants to take that one?
A Barlow is a lens that fits between your eyepiece and the telescope and effectively doubles the magnification of your eyepiece.
Right.
I don't
Or
particularly like
triples.
them myself. Or triples, yeah, you get 3 times Barlow.
Yeah, they're characterized by how much they extend the focal length, 2x,
Yes.
3x Barlows, things like that.
That's right, yeah. I think they can go up to 5 times 5, but why?
You're trying to say what? I'm sorry, I didn't hear what you said. I was reading the code.
Well, they can go up to times 5. But,
Can they go that high? Wow.
I think so. Usually they're either times 2 or times 3. So that means they'll double or triple the magnification factor of your eyepiece. The big bonus of them, going back to eye relief, if you've got a 10mm eyepiece and a 2 times Barlow, that will give you a better eye relief than using a 5mm eyepiece. So it'll be much more comfortable for you to use.
But again, you've just doubled the focal length, reduced your field of view, and increased your magnification all at once. So they may not make your viewing. I've put them in, especially when I'm looking at Jupiter. I'll get a nice thing in my 40mm eyepiece. And oh, that looks nice. Let me pop in a Barlow. I'll pop in a Barlow, and things go to crap. So sometimes, depending on the night sky conditions, they may not be all that helpful. But they're just usually one lens. They're double convex, so they look like this, and they basically, like John said, they increase your field of view or your focal length effectively, and which does a whole host of other things, reduces your field of view, increases your magnification, and are an easy way to play around with the image that without changing eyepieces or anything else. Now the other side of that, the opposite of a Barlow, is something called a telecompressor. And it does the opposite of what a Barlow does. It shortens your focal length, widens your field of view, decreases your magnification, and those are very helpful. They're usually a much bigger thing. They're a bigger lens that goes at the end of a Schmidt-Cassegrain usually. And they're good for imaging. When you want to put a camera on the back of your scope and you want to see, because the pixel scale of a camera is very high. We'll talk about all that later. And so but a telecompressor does the opposite of what a Barlow does. Telecompressors are generally used, however, not visually, but with imaging. So let's see. Tony, don't forget to explore Scientific 100, Scientific 100 and 120 degree. What is that? Is that a telescope brand? What is that, guys? Do you guys know what he's talking about? Explore. Do you see that chat comment there?
Yeah, it's right on top. Yeah, it's are they eyepieces?
Oh, they're an eyepiece. Okay, I didn't know that. I did not know that. So I should explore that, like he suggests. Scientific 100 eyepiece. IECE. Spell it right. Oh, are these Edmund Scientific? Or no? These are just. Oh, they're a brand from Celestron. I get it now. Oh yeah, look at those. Wow, $1,000 for a 30mm 100 degree eyepiece. Now, John, you mentioned when you were talking about field of view, an apparent field of view. What is that? What other kinds of field of view are there?
Well, I think we'll be maybe coming back to that on in more depth on a later show.
Oh, you want to go into? Okay. All right.
There's equations.
Oh, there's math involved. Okay.
There's math involved.
Well, we'll stay away from that for now. But apparent field of view in a descriptive sense, is the apparent degree field of view that you're seeing on the swath of the sky. It may not be the actual field of view, but it may act as if it is a 100 degree or what. I guess these scientific eyepieces give you a 100 to a 120 degree apparent field of view, and they look marvelous. But my goodness, are they expensive? So I'm seeing prices here from $400. Oh, here's some smaller ones for $64. But these, wow, these are really expensive. And Naglers are too, folks. They're like that. They're like $500, $600 for just the eyepiece. Okay, so don't buy any of these eyepieces that we're talking about if you bought your first telescope that we recommended to you, like a 8-inch Dobsonian. Well, I don't know. It'd look good on an 8-inch Dobsonian. Some of these telescopes aren't really worth having these eyepieces for. I think Cassegrains would work best. But I think if you had a good quality 8-inch Dobsonian, it would look pretty good in there. David Sims is going, Ralph Nader was famous for finding problems with consumer goods and false advertising claims. Yes, that's right. He was the one. We look at him here in the United States as the person who killed the convertible. Because
unsafe at any speed.
Unsafe at any speed. You guys remember him. Yeah, so that's right.
Yeah.
Okay, so Kieran is also asking, how should we take care of eyepieces? How to avoid fungus formation, dust accumulation, etc. Okay, now Kieran, I've owned many eyepieces. I've never had one with fungus on it, but they do get dust on them. So, John, Adam, how do you take care of your eyepieces?
A simple lens cleaning kit like you'd get with for your camera. With a brush and a little.
Do you guys use that compressed air also? Do you guys ever use that? Yeah.
Try not to drop them on the floor.
Try not. That sounds like something that happened from experience, Adam. Are you still? Did that actually happen to you?
Yeah.
Okay. Alexander's saying they are perfect, better than Naglers. That must be the scientific telescopes. Well, I don't have personal experience with those, so I can't comment, but I will believe you. They sound awesome. Alexander's also commenting, always clean the tears from the eyepieces. So if you're crying while you look at them, maybe with your eye being open a long time and moisture gets on it, yes, you do want to clear that saline off of the because all of these eyepieces, they're generally their cost. Two things go into their cost: the quality of the optics, because glass is not cheap, this optical glass, and the coatings that they put on the surfaces of these optical elements. They can be quite expensive. They're designed to reduce reflections. They're designed to make the most light go through as possible. And all of the things that we talked about with refractor telescopes are a problem with eyepieces. Things like chromatic aberration and astigmatism. All of these things can pop up in an eyepiece. So those are all been corrected for in a high quality eyepiece. So you can avoid those, but coatings are also an important part of telescope optics. So and moisture, you can scratch the coatings so easy. I don't know about you guys, but I keep one of these on my desk. These are those lens cleaning cloths. I use them on my glasses. I would not use these on an eyepiece because these. Well, first of all, it's been sitting on my desk. It's full of dust, and if I were to start wiping it around on my eyepiece, I'd probably scratch it. Right, so. I don't know about you, but they make these lens cleaning tissues that if you use a clean one every single time, the first time, and then throw it away. In fact, I had a guy who was so paranoid about it that a friend of mine, he would wipe it once, throw it away. Get out another one, put a little bit of lens cleaning solution on it, dab, throw it away. And then he would just go through just scores of those little lens cleaning papers or tissues to clean his optics. And he also had a camel hair brush that he would gently spray or move the dust off of his optical elements with. So that was another way in which he took care of his stuff. Of course, and if you spend $1,000 on an eyepiece, you want to take care of them. So that's a good question.
I think colossal eyepieces are good for a beginner.
Yeah. So if you're a beginner, I couldn't agree more. Those are the best of every world. They give you high quality eyepieces or high quality views. Like I said, you generally get one when you buy a telescope. Usually a 26 millimeter comes with Celestrons, I think. And a Meade, I'm not sure what they give you. Maybe a 26 as well. And Meades and Celestrons, they all have their own brands of eyepieces. But my experiences are all manufactured in the same company company and the same companies in Japan. They tend to make. Do you guys find that too? That they're pretty much the same eyepiece, identical except for the brand.
Slightly different casing, perhaps, but the optics are the same.
Okay, is the sun going down now in the UK?
Yes, it is.
Because you guys suddenly got really dark.
And the clouds have come over as well. So,
all right. Well, we will go ahead and stop there because we've been at this for a full hour. I hope this is helping you folks. Eyepieces and mounts were the subject of today. If you want to continue the discussion, please call in my station, anchor.fm/deepastronomy. Ask your question. I will answer it for you directly. And if I can't do it, I'll get John and Adam to do it for you as well. So please, let's continue the discussion there. I'm also looking at comments and stuff here. Thanks, Kieran, for all of your input on Facebook. It was really great. Thanks to all of you on YouTube. Galaxia, it's good to see you again. Alexander, way to go. Thanks for giving me a hard time, though. I do appreciate that. Thank you. David Sims, it's good to see you also. And we're going to talk about, what do you guys want to talk about next time? Where do you think is a good place to go from here? You want to talk about go-to telescopes?
Yeah, could do. Yeah, go-to mounts.
Go-to mounts.
But here's one thing about eyepieces.
Okay.
These are both the same focal length.
Oh, right. We forgot to talk about your eyepieces. Let's show those.
Yeah, patterns 1¼ inch, which is the most common that you buy.
That's the diameter of the focuser.
Of the bit that goes into your telescope.
Mm-hmm.
This is the 2 inch. And as you can see, if I take the lens caps off, well, it can take the lens caps off. The glass on them is just so much bigger. These are 70-degree field of view. This one, it's too dark to see.
Yeah, I let it get too dark before I show you. I'm mad I forgot those. Yeah,
you'll be looking to be getting 50 degrees field of view out of this one. So
yeah,
a lot heavier, a lot more expensive, but in my opinion, well worth it.
So so for visual astronomy, eyepieces are.
Oh yes.
Yeah, you definitely want the best you can buy. I forgot to talk about that, about 1¼ versus 2 inch focusers. Why don't you mention a little bit more about that?
You said expensive. These are less than £100.
What exactly is it? What brand is it, and what millimeter size is it?
Panaview. This is a 38mm super wide angle, 70 degrees. It's very heavy, so when you're balancing your telescope, especially for an equatorial mount, take this into account.
Okay.
And this one is a colossal. That's a 32mm, so very nearly the same size as the big one. But the eye relief on it is so much better.
Yeah, you find that, don't you, John? That as you're observing, there's your favorite eyepieces. They're the ones you always put in, and that's because they give you the consistently best views.
That's right. Yeah.
Yeah. Okay,
You'll find that you'll buy maybe a dozen or more eyepieces, but you'll always keep sticking to the same ones.
Yeah, that's right. I found the same thing. Okay, well, Adam, any closing remarks you want to make? No? Okay, good. All right, well, so, Galaxia, you're asking if we're going to Twitch now. Unfortunately, I don't have time. I've got to go because I've got other things I've got to get finished up before the workday ends, so I can't do Twitch this week. However, you bring up a good point. I do want to try, whenever possible, after the Hangouts, to move over to Twitch and do a Q&A only on Twitch, just between us, because the interaction tools there are much better than what you get on YouTube. So I can't this week, although I will try and pencil it in next week, and if John and Adam are free, it's not getting too late for them, they might join me over there as well. But unfortunately, I can't do it this week. But still, let's follow up with anchor.fm/deepastronomy. I really want to use that more. I'm excited about that platform. I'm doing daily Your Sky Tonight broadcasts on it. So I'll tell you what's up each day. I don't know how long I keep that up, but I'll try. If you keep listening, I'll keep doing it. And yes, so what is the Twitch name? It's everything. Everything is Deep Astronomy. Twitch.tv/Deep Astronomy is my channel, so follow me there. I'm broadcasting this on Twitch right now, and we're gonna, probably I'm also doing Periscope, but I'm thinking of cutting that out because nobody is ever watching on Periscope, and why bother with something no one's using? So that's where we're heading. They're talking about binoculars now. David Sims has got Orion binoculars. He looks at Jupiter through his binoculars. Yes, that should also be an entire hangout, don't you think, guys? Binoculars.
Yeah.
Yes.
Yeah, we should probably just do a whole thing on that. So send us your ideas in the comment section of this video on whatever platform you're watching. I'm looking at all of them, and if you do a call in on Deep Astronomy on Anchor, we'll also make note of future hangout sessions. And I guess but I need to call it the end of a hangout on this one, guys. So thank you guys very much for watching. Thank you guys for joining me, Adam and John. Appreciate you guys' input. So we'll see you guys next week, where we will probably talk about.
Got 2 months on it.
You think? Okay. Is it time for that? Do you think, or?
We'll talk about something.
All right. Maybe Schmidt-Cassegrains and go-tos. Okay, we'll talk about something. But yeah, I'll think about it. Probably be go-to telescopes, since that is what everybody wants. They just want to turn it on and have it show them everything in the night sky, and I think that's a tragedy if you don't know the night sky already. But nevertheless, it is something you can buy, so we should probably talk about those. Okay, guys, thank you all. For this week. Thank you all for watching Telescope Talk. I appreciate you joining me each and every week. You guys are awesome. Thank you so much for watching, and as always, keep looking.
Keep looking up.
Go.